we've talked about conservation of energy. We've talked about converting one form of energy to another. We know that the total energy has to be conserved. Now that doesn't mean that it all has to go in one place. Maybe as I'm running, the chemical energy in my body partly goes into moving me forward and partly goes into thermal energy and other types of energy that aren't particularly useful. But the total amount of energy has to be conserved. Now we're going to talk about something called power, which is going to tell us how fast energy changes form from one type of energy to another. So I'm going to make an analogy here. So we talked before about velocity, which tells you how your distance changes over time. So if I look at how much I am displaced for a certain amount of time, that tells me how fast I'm moving. Well, power is very similar to velocity because it is also a rate at which something is changing, except in this case, power is equal to the rate of change of energy over time. So if I look at how much, I take this piece of chalk and I drop it, it is converting from gravitational potential energy to kinetic energy. Let's say you lose 10 joules of energy in every second, then your power would be 10 joules per second. That's what power is. It's fairly simple. It's the number of joules you waste every second, or change, it doesn't have to be wasted. Which means that the units of power are going to be joules, because energy is measured in joules, divided by the units of time, which is in seconds. So it'll be joules per second, and we come up with another name for this. This is called a watt, or W for short. After Watt, who did a lot of work with energy and power, so we named a unit after him. So you should know, if I ever ask you, what is the unit of power, you should say yes. What is the unit of power? Because watts are the unit of power. Okay. Bad joke? Watt is the unit of... Okay, never mind. You guys are terrible. Okay, so let's do a quick example of power. I want to compute the average power of a human being. Average power of a human. So we know power is just energy over time. Change in energy over the change in time. Well, how much energy do you take in on average? Well, what type of energy does your body use? Where does it come from? It comes from food calories. How many calories does a typical person eat in a day? Well, it could be anywhere from 1,000 to 2,000, depending on who they are, their body type, how hungry they are. I'm going to say 2,000 calories a day. Now these are food calories, and remember that food calories are actually kilocalories in the chemistry or physics sense. So that's 2,000 kilocalories per day. So my time would be 1 day. So how many watts is that? What can I compare that to? So how powerful is a human being? Well, we said it's 2,000 calories per day. So let's just type that in, 2,000. Now it's a food calorie, which is actually kilocalorie. We'll say per day. And if we type that in, we get about 97 watts, about 100 watts. So each one of you guys are just like little batteries. You're outputting, or taking in and outputting, about 100 watts per day. So you're just kind of like a light bulb. Each human body is giving off about the same amount of energy as a light bulb.